Hi, my name is Burse. I'm the CDO at Prasa. We build data centers for a living, and I personally love to solve complex problems in the data center space. When we take the term called liquid cooling, predominantly it talks about using liquid more than the air to cool the servers or the chips. Liquid cooling per se as a concept or a technology has been in this industry for over a decade. I remember talking to a few of my clients and customers back in 2014-15 when liquid cooling was already present. What is liquid cooling is something which remains a debate because there are multiple types of liquid cooling. The liquid itself has two categories. One is the single phase liquid cooling, then you have the dual phase liquid cooling, where the dual phase liquid cooling evaporates and then converts it back into liquid to cool it down. The single phase liquid cooling is a circulation of liquid cooling where a heat exchanger is trying to exchange the heat to make sure that the cooling is happening. In this space, you have liquid immersion cooling. We as Prasa had brought the liquid immersion cooling as the first mover in India. That was in early 2020s, about in 2021 I think, when one of our customers wanted to do a proof of concept of liquid immersion cooling, and we got the tank and deployed it here. The other type of liquid cooling is the direct contact liquid cooling, which is basically also known as DLC or DCLC, which is nothing but moving the liquid on top of the chip, actually not touching the chip, but making sure it moves on the top of the chip to exchange the heat from the chip and take it out. This is the broad understanding. Now, there are various components which are extremely critical in terms of ensuring that the liquid cooling performs the way it needs to perform. Three major components is what I would like to highlight on, and I'll start with the server. The server has a chip on it. It is the GPU brought from the likes of Nvidia, AMD, Intel, also at some places I think. The GPU is getting heated up. The TDPs of the GPUs are going way above what a typical CPU would be. These power consumptions on the chip are getting converted into heat, and how we extract the heat is nothing but a uniquely designed heat sink, which is called as cold plate. The heat sink which would let the air pass through it and then bring the heat out. These are cold plates where you have capillary tubes inside the cold plate, which basically make sure that the heat is transferred from the chip to the liquid flowing through the capillary tubes. So that's component number one. Now that is going to go into the next component, which is the manifold, which is mounted on the rack, mostly besides the rack PDU at the back of the rack, where the pipe from the server will come and get terminated there using a quick coupling connector. That's component number two. Then you have component number three, which is the CDU, the coolant distribution unit, which is probably one of the most important components of the three. Of course, the cold plate is critical, but the CDU and its performance is also extremely critical in order to ensure that the heat extraction and cooling happens. Beyond this, now how do we make sure that the liquid moves from the CDU to the manifold and the manifold to the cold plate and back from cold plate to the manifold and manifold to the CDU? That we call as the technology water loops, also known as SFN, secondary fluid networks. The SFN is a very, very critical piece of the puzzle, which has a metallurgical quality of being pure. That is a requirement, and hence the choice of metal that is being done in today's requirement is the stainless steel pipes. The stainless steel SS304, it may also lead to SS316 if the requirement goes higher, but currently 304L is what is chosen as the metal required to connect the CDU to the manifold. And that is becoming very, very, very critical, because any kind of an impurity or any kind of leakages in that loop will break the cycle of the water or the liquid that is going to the chip. And the moment that cycle breaks, the chip is likely to get heated in no time. And that's going to lead to chip frying. And as you know, the NVIDIA chips or any other GPU chips or AI servers are extremely costly. We're talking about $4 or $5 million per rack. And the technology water loop, the SFN, is something that is connecting multiple racks together. So if that fails, you have $4 million into multiple racks that are going to be useless. The SFN nowadays is being asked to make sure it is clean, it is welded with the latest technology of orbital welding and laser welding techniques, and it is passivated. I won't be surprised in the near future if they ask for electroplating as well. And that is where we at Prasa have heavily invested to ensure that we are in the space catering to the large requirements of large data centers for setting up the secondary fluid networks. So secondary fluid networks, apart from the right combination of material, right techniques of welding, high quality passivation and cleaning processes, high quality pressurization techniques to make sure there's absolutely no leakage. Beyond that, you also have a few other components like the stainless steel valves, and one of the most critical component in all of this is the connector which connects the manifold hose pipe to this SFN. And that connector currently, which is dominant in the market, is the FD83 connector. The FD83 connector is a very high efficiency, high quality component which has an extremely low failure rate or almost no failure rate, is what is being contemplated right now. And that is the important portion in the complete SFN network beyond the quality of the pipe itself. With Prasa's ability and experience of doing high density racks in the past, we have a deep understanding of ensuring that how this particular network of pipes have to perform to ensure that the cooling is taking place seamlessly. And that being said, it moves me to another important topic here, is the assurance that a company can give to make sure that the secondary fluid network performs year after year. Another most critical requirement is to be able to perform the flushing activity of the SFN loop at site. Once the loop is manufactured, prefabricated in a frame, it should go at site and get installed. So once you take it there, it's extremely critical to make sure you have a skid arrangement where you have thousands of liters of distilled water which gets flushed through the loop to make sure the purity is maintained. The huge dependency here is the availability of distilled water and making sure you get it on time. In order to solve this problem, what we have done at Prasa is developed our own distilled water plant. And we bought the boilers, we bought all the equipment that is required, and we are ensuring that we have seamless supply of distilled water. That is another advantage that helps the customer to be less dependent on the supply chain of various vendors and make sure you have a single point of contact for the whole project.